Welcome back to the Deep Dive. It is genuinely great to have you here with us. Today, we have quite the spread on the table.
You mean that literally?
I really do. We're looking at a massive stack of research papers, clinical trials, and, deep chemical analyses that cover this entire spectrum of biochemistry. We're going from, the heavy metals in the Earth's crust to the petals floating in your teacup.
It's a fascinating mix today. And if you look at the source list we've pulled together, we are essentially putting what people call nature's pharmacy on trial.
Which is a trial I think is long overdue. We all have that one friend who swears by herbal remedies for everything, right?
Oh, yeah.
The one who tells you to chew on a root when you have a headache. Or, maybe we've all read those splashy headlines about the latest superfood that's supposed to cure everything from fatigue to the flu.
Right.
But the goal of this deep dive is to push past the marketing and honestly past the folklore and see if these things actually hold up against the cold, hard scrutiny of modern science.
And we have the source material to do it. This isn't about lifestyle blogs or anecdotal forums today. We have data. We're going to be dissecting the role of zinc in human physiology.
Okay.
We're examining a specific study on traditional herbs used for sore throats in Pakistan, digging into Polish research on plants that fight diabetes, reviewing adaptogens like ginseng for athletes, and then finally looking at the surprising biochemistry behind chamomile.
So the mission is clear. We are sifting through the noise to find the signal. We aren't just going to say, eat your veggies.
Well,
We're going to look at specific molecules, things with names like apigenin, ginsenosides, and DNJ to understand how these things actually work in the body, because that's where the real story is.
that's the key mechanism. I mean, it is easy to say this herb is good for you.
Mhm.
It is much harder, and I think much more interesting, to explain that a specific molecule binds to a specific receptor in your brain to calm you down.
Exactly.
That is the standard we are holding these sources to today. We want to know the why and the how.
I love that. So let's unpack this. Our title today is Bioactive Compounds, from metals to petals. And logically, I think we should start with the foundation, the metal.
Zinc.
Zinc.
Or zinc, if you're looking at certain periodic tables.
Yeah.
It is often overlooked, isn't it? We usually think of it as something you find in a cold lozenge, maybe.
Or that white paste lifeguards put on their noses.
Right, exactly. But in the scientific literature we have here, it is referred to very differently. It's called a microelement of health, or even, and I love this phrase, the metal of life.
Metal of life. That is a hefty title for element number 30. I was looking at the history notes here. It was isolated as a pure metal way back in 1746.
A long time ago.
Yeah, by a German chemist named Andreas Marggraf. That's mid-18th century. But reading through the papers, it seems like for a long, long time, we knew it was there, but we didn't really get what it was doing inside of us.
Precisely. We knew it existed chemically, but its physiological role was a mystery until much later, really well into the 20th century. Now, though, looking at this review, we know it is ubiquitous. It is just everywhere.
In body, you mean?
In the body. Zinc is present in numerous enzymes. Specifically, and this is so crucial, it's a key component for DNA and RNA polymerases.
Okay, let's pause and define that for a second because that sounds super technical, but it's actually fundamental to life. DNA and RNA polymerases, those are the enzymes that build and copy our genetic material, right?
They're the master builders.
Correct.
Think of your body as this constant construction site. Cells are dying and need to be replaced, every second of every day.
Nonstop.
To build a new cell, you have to copy the blueprints, the DNA. The enzyme that does the actual copying, the polymerase, requires zinc to function. It's what's called a cofactor.
So without zinc, the copier it breaks.
The copier doesn't just break, it doesn't even start. Without sufficient zinc, your body cannot effectively synthesize protein or replicate DNA. It is the fundamental cofactor for growth and repair.
Wow.
If you don't have enough zinc, the construction site that is your body essentially runs out of skilled workers. Everything grinds to a halt.
That explains why the research highlights it being so important for kids and pregnant women. People who are doing a lot of building.
Of course.
If you're growing a human or just growing yourself, you need that copier running 24/7. But I was really surprised to read that the brain actually has the highest content of zinc in the body. Why does the brain need so much of this metal?
Well, the brain is just a massive consumer of zinc because it acts as a modulator of synaptic transmission.
Okay, break that down for us. Synaptic transmission.
So think of your neurons firing signals to one another. You have a thought, a feeling, a command to, move your arm. That's an electrical and chemical signal jumping a tiny gap between neurons. That gap is the synapse. Zinc is located in what are called the presynaptic terminals, the sending end of the signal.
The launch pad.
The launch pad, exactly. It helps regulate the traffic of neurotransmitters. If you are deficient, you get disturbances in that transmission. The signals get fuzzy or they get misregulated.
Which connects directly to some of the darker aspects of deficiency mentioned in the source material. It explicitly links low zinc levels to depression.
Yes, this is a very significant area of research. Multiple studies have shown lower zinc concentrations in the blood of patients suffering from major depression compared to healthy individuals.
So it's not just a correlation, they think it's causal.
There is evidence for it. They've even shown that zinc has antidepressant-like activity in animal models. It's not just about building cells, it's about mood regulation. It seems to stabilize the neural environment. So if the chemistry is off, the mood is off.
That's a powerful connection, that a simple metal deficiency could manifest as a serious mental health struggle. And speaking of senses and nerves, there is this really specific connection between zinc and taste. I remember hearing that losing your sense of taste was a symptom of some viral infections recently, but apparently it's a classic sign of zinc deficiency too.
It is a very classic sign, and we know exactly why.
Okay.
Zinc is a cofactor for a specific protein called gustin.
Gustin. That is a very appropriately named protein.
Right, very appropriate. And gustin is essential for the growth and maintenance of your taste buds. So if you don't have enough zinc, your body can't make functional gustin.
So your taste buds can't regenerate.
Exactly. This leads to dysgeusia, which is the medical term for the distortion or complete loss of taste.
So food literally starts tasting like cardboard.
Cardboard or metallic or just wrong.
Yeah.
It is often one of the first signals that something is off in your diet. Your body's telling you, hey, I don't have the materials to maintain your sensory inputs.
Okay, so we've got brain health, we've got taste. But here is where it gets really interesting for me, especially given the global health landscape. Diabetes. The research mentions that zinc is actually found inside the pancreas.
This is critical. We often think of insulin just as a hormone floating around in the blood. But zinc ions are essential for the biosynthesis of insulin. They are found right there in the beta cells of the pancreas.
The insulin factories.
Those are the factories, yeah.
So what is it doing in there? Is it like an ingredient in the insulin?
It's structural. The zinc ions actually form these crystalline complexes with the insulin polypeptide chains. They help package the insulin into granules so it can be stored properly and released effectively when you eat.
So it's like the packaging.
It's the packaging. Think of zinc as the crate that holds the insulin bottles, right? Without the crate, you can't stack them, you can't store them, and you certainly can't ship them out efficiently when your blood sugar rises.
So if you are low on zinc, your body literally struggles to package its own insulin.
Exactly. A deficiency can lead to increased glucose tolerance, meaning your body is worse at handling sugar because the very machinery that builds and stores the insulin is compromised. It is a fundamental structural component of how we manage our energy.
That is just wild. It's like trying to run a shipping company without any boxes.
And looking further down this list of zinc's greatest hits, we have reproductive health. The source material gets pretty specific here about prostate health and male fertility.
It does. The prostate gland and sperm plasma have very, very high concentrations of zinc compared to most other tissues in the body. It's crucial for spermatogenesis, which is the creation of sperm, and also for maintaining testosterone levels.
So a deficiency could have a pretty direct impact.
A huge impact. It can lead to reduced sperm viability and even issues with potency. It is a major, major player in male fertility.
It really seems like there isn't a single system this metal doesn't touch. We even have a cancer connection mentioned here, specifically regarding antioxidants.
Now, antioxidant is a buzzword we hear in marketing all the time. But chemically, what is zinc actually doing?
So it's part of a key defense enzyme, specifically an enzyme called zinc-copper superoxide dismutase.
Okay, that is a mouthful. Let's call it SOD for short.
SOD. Its job is absolutely heroic. It prevents oxidative damage to your DNA.
What does that mean, oxidative damage?
So when your cells produce energy, they create these metabolic waste products. These are called free radicals, like superoxide. These things are dangerous, they're highly reactive, and they can literally smash into your DNA and break it.
Okay, so SOD is the bomb squad.
It is the bomb squad. That's a perfect analogy. It uses zinc to find and neutralize those radicals. It diffuses the explosives before they can cause a mutation in your DNA. Because if that damage happens, specifically to the purine bases in your DNA, it's a primary cause of carcinogenesis,
The start of cancer.
the start of cancer.
The notes mention a specific type of lung cancer here, where this whole balance is thrown off.
Yes. In non-small cell lung cancer, researchers have observed a distinct imbalance in the ratio of copper to zinc in the body. It can even serve as a biological marker
Why that ratio?
because the enzyme is zinc-copper superoxide dismutase. It needs both. When that ratio gets thrown off, the defense system we just talked about is compromised. The bomb squad is understaffed, and the damage just accumulates.
So if zinc is this metal of life and it's so critical, why would anyone be deficient? I mean, we eat food. Is it just that hard to get?
Well, it's not just about your intake. It is about absorption. And this is the tricky part. You can eat plenty of zinc, but a lot of things can block it from actually getting into your bloodstream.
Like what?
Alcohol is a big one. It inhibits absorption, and it also increases excretion through urine. Stress is another. It physically depletes your body's zinc stores. But diet plays a huge role, specifically for vegetarians.
I noticed the source mentioned a warning for vegetarians. Why is that?
Yes. So many plants contain compounds called phytates. These compounds bind to minerals like zinc in your gut. They form an insoluble complex. They hold onto it so tightly that your body can't absorb it.
So the plant is basically hoarding the zinc.
In a way, yes. It binds it up so your body can't access it. On top of that, high intake of calcium and iron can compete with zinc for the same absorption transporters in the gut. It is a constant battle for absorption.
So the logical leap some listeners might be making right now is, okay, I should go buy a zinc supplement right now and take a handful.
And the source material is very, very clear. Do not do that.
Right.
Supplementation absolutely should be monitored by a doctor. Excess zinc can actually block the absorption of copper and iron, leading to things like anemia.
Yeah.
It is a very delicate balance. You want enough to fuel those enzymes, but not so much that you start knocking out other essential metals.
Balance, as always. Well, speaking of balance, let's transition from the metal that helps make insulin to the plants that might help us manage what insulin controls. Sugar.
This is a perfect segue. We are moving from the mechanism of insulin creation, packaging it with zinc, to the management of type 2 diabetes using what they call hypoglycemic plants.
And the context here is pretty grim. The WHO data in our notes mentions 422 million adults with diabetes back in 2014.
That number is almost certainly much higher now.
It's a massive issue.
It is a global epidemic.
Yeah.
And while our modern pharmaceuticals are effective, there is a huge body of research, specifically this Polish study we are looking at, searching for plants that can support standard treatment.
Okay, so we have a lineup of these plants here. Let's start with one called white mulberry, Morus alba. This one seems to be a heavyweight champion in this arena. So how does a mulberry fight diabetes?
White mulberry is fascinating because we know the exact mechanism of action. It isn't, some kind of magic. It's pure chemistry. It contains a compound called 1-deoxynitromycin. We can just call it DNJ.
DNJ. Got it. And what does DNJ do in the body?
It acts as an inhibitor of an enzyme called alpha-glucosidase.
Okay, we need to translate that. Alpha-glucosidase, what is that?
So think of alpha-glucosidase as a pair of molecular scissors in your gut. Its job is to cut up complex sugars, like the starches from bread or potatoes, into simple sugars like glucose.
And only the simple sugars can pass into your blood.
Exactly. The complex ones are too big, so the scissors cut the starch, and then the glucose rushes into the blood.
So what does DNJ do to the scissors?
DNJ essentially tapes those scissors shut. It blocks the active site of the enzyme. It stops the enzyme from cutting up the starch.
Oh, wow. So the sugar doesn't get released as quickly, and that massive post-meal spike in blood sugar is flattened out?
Precisely. It reduces glucose absorption right there in the gut. It's a very mechanical, enzymatic way of controlling blood sugar. It's not changing your insulin. It's changing how much sugar hits your system in the first place.
That is incredibly specific for a plant. It's like a targeted drug. Okay, next on the list, we have the common bean, Phaseolus vulgaris. I usually just think of beans as a source of fiber and protein, but this is focusing on the pod.
Yes, the pericarp or the pod itself. Usually this is the part we throw away when we're shelling beans, but it turns out the pod acts on two different fronts.
Okay.
First, it contains chromium salts. And remember, we just talked about metals. Chromium is a mineral that helps to enhance the effect of insulin, making it more efficient.
So it makes your own insulin work better.
Right, but the bean pod also has an alpha amylase inhibitor.
Another inhibitor.
Yes, alpha amylase is another enzyme that digests starch. So just like the mulberry, the bean pod helps prevent that massive dump of sugar into the bloodstream after a starchy meal. It's fascinating that the part of the plant we often discard is actually the part that regulates how we metabolize the seed inside.
It really is. Okay, moving on to something I usually associate with curries.
It,
Fenugreek. The seeds, specifically.
Fenugreek is interesting because it works both physically and hormonally.
How so?
First, the seeds contain these things called galactomannans. These are basically gummy, soluble fibers.
They're kind of sticky.
Yes. When you eat them and they hit the moisture of your digestive tract, they form a viscous gel in your stomach.
Okay.
This gel physically increases the viscosity of the food, which delays the emptying of the stomach. So if food leaves the stomach slower, sugar enters the blood slower. It's a simple mechanical process.
That's the physical part. What's the hormonal part?
It also contains a unique amino acid called 4-hydroxyisoleucine. This compound has been shown to directly stimulate the beta cells in the pancreas to release insulin.
So it's a double threat.
It's a double threat. You have a mechanical slowing of digestion combined with a hormonal boost to insulin release. The clinical results were pretty clear. 8 weeks of powdered seeds reduced fasting glucose and triglycerides in patients.
That's significant. Okay, I want to skip ahead to one on the list that really blew my mind because of the direct historical connection to modern medicine, Galega officinalis.
Ah, yes. Go through. This is perhaps the most important plant in the entire history of diabetes treatment.
Why is that? What makes it so special?
Because Galega contains a compound called galagine. Chemically, it is what's known as a guanidine derivative. Back in the Middle Ages, herbalists knew this plant lowered blood sugar, but it was too toxic to use reliably as a drug.
So it worked, but it was dangerous.
Exactly. It would help the diabetes, but it might also poison the patient. Not an ideal trade-off.
No. Your blood sugar is great, but you're dead.
Not ideal at all.
Mm-hmm.
But in the 20th century, chemists looked at galagine. They used it as the blueprint, the structural inspiration to create a safer synthetic version. They tweak the molecule to keep the benefit and lose the toxicity.
And that synthetic version is?
Metformin, the most widely prescribed diabetes drug in the world today.
Get out of here, really. So when millions of people take their metformin tablet today, they are essentially taking a synthetic, optimized version of a compound found in a wildflower.
Yes. It connects the herbal past directly to the pharmaceutical present. It shows that nature's pharmacy isn't just a metaphor. It's often the R&D department for modern medicine. We didn't invent the mechanism. We found it in a plant, and we refined it.
I love that idea. Nature is the R&D department. Okay, let's move from these chronic conditions like diabetes to something acute and, frankly, pretty urgent. We're looking at a study concerning the sore throat squad.
Right, this is a very specific study. It involves 29 traditional herbs used in Pakistan for respiratory ailments. And the context here is high stakes, multi-drug resistant bacteria, MDRs.
Superbugs, MRSA, the kind of stuff that hospitals are terrified of.
Exactly. Antibiotics are failing. Bacteria are evolving faster than we can invent new drugs to fight them. So these researchers took these traditional sore throat herbs remedies people have used for hundreds of years and pitted them against some really nasty bacteria like Staphylococcus aureus and Pseudomonas aeruginosa to see if they actually kill them.
So did the folklore hold up, or was it just, a placebo effect all these years?
It held up surprisingly well. Out of the 29 plants they tested, 18 showed antimicrobial activity.
18. That is a pretty good hit rate.
A very good hit rate for this kind of screening.
Who were the top performers? What were the standout plants?
The biggest standout was Adatoda vasica, which is also known as Malabar nut. It showed really strong activity against Staph aureus. The plant contains bioactive alkaloids that seem to be disrupting the bacteria's cell processes.
And we also saw some common kitchen favorites on the list, right? I recognized a few.
Yes, absolutely. Oregano, Organum vulgare, and thyme, Thymus vulgaris. We often think of them just for flavor, but the essential oils in these plants, compounds like thymol and carvacrol, are potent antimicrobials. They showed significant zones of inhibition on the petri dishes.
Which means they created a clear circle where no bacteria could grow.
A kill zone, exactly.
Now, I have to ask about the methodology here because the notes mention something called bioautography. It sounds like a technique from a sci-fi movie. Can you explain what that is?
It is actually a very cool visual way of doing science. Usually when you test a plant, you just dump the whole extract on a dish of bacteria. But with bioautography, they use a technique called thin layer chromatography first. They spot the plant extract on a special plate and run a solvent through it.
Yeah.
This spreads all the different chemicals out into separate bands or dots, kind of like a rainbow or a spectrum.
So you separate the plant into its individual ingredients on a little strip.
Exactly. Then, and this is the really cleverer part, they spray a suspension of the bacteria directly on top of that strip and let it grow.
Oh, wow.
So after incubation, you look at the plate, you see a film of bacteria growing everywhere, except for a clear dead zone right over one specific spot on that strip.
So you know exactly which molecule in the plant is the killer.
Precisely. It allows you to pinpoint the active weapon in the plant's chemical arsenal. It's a brilliant technique.
That is fascinating. It's like a target map for new drugs. But what about safety? I mean, just because it kills bacteria doesn't mean it's safe for us. Bleach kills bacteria, but I'm not gargling with it.
A very valid point. And one the researchers took very seriously. This study also tested for toxicity using a method called hemolysis.
Hemolysis.
They exposed human red blood cells to the extracts to see if they would burst.
If the red blood cells pop, it's probably toxic.
That's a good sign it's toxic, yes. And the good news, for most of these extracts, they caused less than 1% hemolysis. They were very, very safe at the concentrations tested.
Okay, that's reassuring.
It is. It helps validate their long history of traditional use. There was one exception, though, a plant called Cordia latifolia. It showed high antibacterial activity, but also the highest level of hemolysis.
So it kills the bug, but it also might damage the host.
It was still within what's considered a safe limit for humans, but it was on the higher end. It shows that potent biological activity often comes with a trade-off. It's a great reminder that these are active compounds, not just flavored water.
Which brings us perfectly to a category of supplements that are very active, very potent, and absolutely huge in the fitness world right now. Adaptogens.
Adaptogens, a term coined by a Soviet toxicologist, Lazarev, I believe, back in 1947.
The Soviets were really into this for their soldiers and athletes, weren't they? They were looking for an edge.
They absolutely were. The whole theory is based on Hansel's general adaptation syndrome, his model of stress.
Right, the 3 stages: alarm, resistance, exhaustion.
Exactly. The idea behind adaptogens is that these substances help the body resist nonspecific stress. They extend that middle resistance phase, delaying the point where you crash and burn.
So we have a lot of athletes taking these to perform better. Let's look at the big one, ginseng, Panax ginseng. Does it actually make you run faster or lift heavier? What do the studies say?
Well, the proposed mechanism is that it influences the HPA axis. That's the hypothalamus pituitary adrenal axis, our central stress response system. The theory is that it helps spare glucose by forcing the body to use lipids or fats for energy instead.
Which sounds great on paper. Burn fat, keep the sugar for the final sprint. What does the actual data say?
The animal studies were great. I mean,
Yeah.
mice given ginseng extract swam for significantly longer before exhaustion. But the human studies, they're very mixed. And here is the nuance that I think is the key takeaway from the review. Studies on elite athletes often showed no significant improvement in VO2 max or endurance.
Really? So if you are already at the peak of human performance, ginseng might not push you any further.
That's what it looks like. It appears to be more effective for, say, recreational athletes or untrained individuals. It can improve psychomotor performance and reduce lactate production in regular folks.
So it helps the weekend warrior more than the Olympian.
It seems that way. If you are an Olympian, you are already operating at your genetic ceiling. Your training has pushed you there. Ginseng isn't a magic turbo button that breaks physics for you.
That is a really, really important distinction. What about the golden root, rhodiola rosea? I see this in every pre-workout drink nowadays.
Rhodiola is another interesting one. The key chemical markers for the genuine plant are 2 compounds, rosavin and salidroside, in a specific 3-to-1 ratio. If it doesn't have that, it's probably not the real deal.
And its mechanism?
It's thought to increase beta endorphins, activate AMPK, which is a master energy regulator in your cells, and also act as an antioxidant.
And the results for athletes?
Pretty similar to ginseng, actually. There is some evidence it reduces fatty acids and markers of muscle damage, like creatine kinase, after exhaustive exercise. It can help with fatigue, but again, it seems to work best for general fatigue or people who aren't already elite conditioning machines.
I guess the question everyone asks in the sports world then is this doping?
A fair question. Currently, no. It is perfectly legal. No banned substances are found in urine after use. It is considered a nutritional support, not a performance-enhancing drug in the regulatory sense. So you can take your ginseng without worrying about the anti-doping agency knocking on your door.
Good to know. So we've revved up with zinc and ginseng. Now, I kind of want to wind down. Let's talk about the soothing giant, chamomile.
One of the oldest and most widely used medicinal herbs known to mankind. We consume apparently over 1 million cups of chamomile tea per day globally.
That is a lot of tea. And we all know the cliche, drink chamomile to help you sleep. But is there actual biochemistry happening there, or is it just the calming ritual of holding a warm cup that makes us sleepy?
There is absolutely biochemistry happening, and it comes down to a specific flavonoid in the flower called apigenin.
Apigen. Okay, what does it do?
This is the fascinating part. Apigenin binds to benzodiazepine receptors in the brain.
Wait, benzodiazepine as in like the same receptors as Valium or Xanax?
Exactly the same receptors. Valium and Xanax target these receptors to induce sedation and reduce anxiety. Apigenin does the same thing, just with a much milder effect.
So it's not going to knock you out like a prescription drug.
No, but it hits the same biochemical button. It is, for all intents and purposes, a non-addictive, gentle biochemical sedative.
So it literally is nature's Valium. That validates centuries of grandmotherly advice right there. But the research stack we have here mentions some uses for chamomile that go way beyond just sleep.
Oh, yeah.
The one about infants and colic really stood out to me. That seems like a huge deal for parents.
This was a very compelling study. They looked at infants with colic, babies crying for hours in obvious distress. It's a nightmare for parents. They gave these infants an herbal tea that contained chamomile.
And this was a proper trial compared to a placebo.
Yes, and the result. The colic was completely eliminated in 57% of the infants who were treated with the chamomile tea.
57%. Wow. And the placebo group.
Only 26%. That is a statistically significant difference. It strongly suggests that chamomile acts as a digestive relaxant, an antispasmodic, soothing those spasms in the gut that cause the pain.
That could save a lot of parents a lot of sleep. There was also a mention of wound healing, which I didn't expect.
Yes. In dermabrasion studies, so think tattoo removal or skin resurfacing procedures, chamomile was applied topically as a cream.
And
it actually sped up epithelialization, which is the regrowth of the outer layer of skin, and the drying of the wound faster than corticosteroids did in some cases.
faster than steroids, that is impressive.
It is. It speaks to the anti-inflammatory potency of the volatile oils in the flower, things like bisabolol and chemazoline.
But in the spirit of being objective, and this is what I like about doing this deep dive, we have to mention what it didn't work for. The source material is clear about its failure in treating mucositis.
Right, and that's important. Mucositis is a painful condition where chemotherapy drugs cause terrible sores in the mouth. They tested a chamomile mouthwash to see if it would help soothe that inflammation.
And it didn't.
It did not work any better than the placebo.
I think that is so important to highlight. Just because an herb is anti-inflammatory doesn't mean it works for every single type of inflammation in the body.
Exactly. It has its strengths and it has its limits.
Yep.
And we should also mention the safety note. Chamomile is in the Asteraceae family. That's the daisy family.
So if you are allergic to ragweed or chrysanthemums,
You might have an allergic reaction to chamomile. It is pretty rare, but it definitely happens. If you sneeze around a bouquet of daisies, you might want to be careful with the tea.
good practical advice. So we have covered a lot of ground today. I mean, from the zinc mines of 1746 to the tea shops of today.
It's a journey from the atomic level, really, to the whole organism level.
When you look at the big picture of what we've discussed, what stands out to you? For me, it is the specificity of it all. We aren't talking about magic or some vague energy. We are talking about a zinc atom fitting into an insulin molecule like a key into a lock.
Yes.
We are talking about a molecule from a mulberry literally blocking a specific pair of enzyme scissors. We are talking about chamomile hitting the exact same brain receptor as a pharmaceutical drug like Valium.
That is the takeaway, 100%. Nature provides these incredibly potent compounds, alkaloids, flavonoids, saponins, but they are chemicals. Just like drugs are chemicals, they have mechanisms, they have dosages, and they have side effects and interactions. The so-called magic is actually just complex biochemistry that we are finally mapping out.
And it makes you wonder what else is hiding in plain sight.
It really does.
Yeah.
Think about it. Galega officinalis was just a common plant until science turned its active compound into metformin, a drug that helps millions of people manage diabetes. Willow bark was just bark until we isolated the active compound and created aspirin.
So the provocative question to leave our listeners with is this. We looked at 29 sore throat herbs from Pakistan today. 18 of them killed superbugs in a petri dish.
Right.
So is the next blockbuster antibiotic, the next penicillin, currently sitting in a teapot in a village somewhere, just waiting for us to do the bioautography and isolate the right molecule?
It is almost a certainty that it is. We just have to keep looking.
A fascinating thought to chew on, or maybe to sip on. Thank you for joining us on this deep dive into nature's pharmacy. Stay curious, keep learning, and we will catch you next time.